Hi everyone, welcome. This session is called Exploring a Risk Approach to Software Supply Chain Security. My name is Abdullah Garcia. Just a brief bio. I work for JP Morgan. I'm a senior lead cybersecurity architect, and I've been working with cloud native, software supply chain, SaaS, API security, and whatnot, right? So I hope that this session is helpful, and I'll be happy to take any questions throughout it, okay? So what's our agenda today? We're going to run through some basic concepts. We're going to go through external software supply chain and the threats, internal software supply chain and threats, software supply chain attacks and the breakdown. I'll speak to you about risk, the risk-based deployment model, and the areas of opportunity and what is next, right? So let's kick it off. Let's level set, right? So some of you might know it, some of you might not, right? But you have what you call traditional supply chain, which is basically everything that happens for you to get a service or a product, right? It can go from factory, transportation, everything, organization, everything. Well, the same is true for software supply chain, right? You have the same elements, but in different forms. You have source dependencies, engineering, network, application repositories, and the deploy systems altogether. Now, software supply chain security is basically how do we protect every single thing across this software supply chain, right? The artifacts, the processes, everything that is involved, okay? So, let's start with external software supply chain. In the external software supply chain, we find at least these points of attacks, right? You have personal software development environments that are, as an example, the OSS maintainers' laptops, right? You have public source control management platforms such as GitHub, where you find the source code of the application that's being used or the dependency that's being built. You have public build infrastructure services such as Circle CI, which allows you to run CI/CD pipelines, right? And they consume this source code effectively to produce something. You have the public software registries such as NPM, PyPy, and whatnot, where you can find these already like compiled artifacts, if you will, right? And they can be channel, proxy, or a source altogether. You have third-party software. Sure, you have heard of SolarWinds, but you can think about other examples as well in the industry. And you have CSP marketplaces, such as AWS Marketplace. Now, it's important to understand that the external software supply chain is something that you want to influence, but you cannot actually change yourself, okay? And that differentiation is important because that speaks actually later to what we identify as your internal software supply chain. Now, sorry. So within the external software supply chain, part of the analysis was to identify existing threats. Now, I don't expect you to read all of it, right? The slides are available for you to download at another time, but the point is that these are very real. These techniques can be actually kind of like gathered in four main ones, if you will: development, name confusion, code injection, and distribution, right? And there are variations, but these affect the external software supply chain, and they eventually manifest in the internal software supply chain altogether. So, before I carry on, I'm going to change a little bit the format perhaps, but I'm happy to take questions as I go along, as long as they have to do with the material I already presented. So any questions about this? No? All right, great. Let's move on. So what do we characterize as our internal software supply chain? So think about it. In the usual perspective, it will speak to the SDLC process, where you have a development environment that actually contributes to a source repository. That source repository might trigger a build pipeline, right? Depending on how you actually do dependency management and your strategy behind it, you will have a package registry. And then from that package registry, the deployment pipeline will pull out and will deploy it into an execution environment. I'm being purposely calling out an execution environment because it doesn't really matter whether it's dev, UAT, or prod, right? It's somewhere where the artifact or the software is going to be executing, okay? Now, this is where the changes can actually happen and where you can actually take control over your supply chain, okay? So we have done the same kind of analysis. Again, you can see this when you download it, right? But there are several attack points or threats that correspond to your internal software supply chain. And what you're seeing there is that it can happen at any point from ingestion, the way that you put things in your source repository, the code that actually embeds with the dependencies, when you put it in the build pipeline, when actually that build pipeline pulls dependencies from your package registry to actually embed them and compile them, and all the way to deployment pipeline. Now, we're not covering execution environment, but I'll get to that towards the end. But that's kind of like the gist of it, right? So not only you care for what happened externally, but you also should care for what can happen internally in your software supply chain. Now, how does that speak to the part of like, how does this combine all together, right? We're coming from a location which is external to your internal location. We're coming from third-party software, dependencies, open source software, and open source dependencies to a fixed version that you're ingesting, right? And the process altogether is ingestion, procurement, inventory, consumption, and development. But here's the key part, right? Whatever happens externally, you cannot control, and that will speak to a specific MITRE enterprise tactics, right? Which would be reconnaissance, resource development, and initial access. And then that will manifest in your internal software supply chain in any of the other possible tactics or techniques altogether. And that's the key part, right? It can be anything. If you look at the MITRE ATT&CK enterprise matrix, you're going to see, I don't know, over 200 techniques related to different tactics, right? And the question then becomes, so what can someone really do about this, right? Like, how do you manage it, right? So let's interpret things first, right? So a software supply chain attack is an attack with potential business impact that exists within an attack chain that originates from the software supply chain, okay? Now, this attack cannot always be stopped at ingestion, even though putting efforts in ingestion is recommended, right? And it cannot be defended directly, right? So, questions about this before I move on? No? You can raise your hands. No wrong questions here. Okay, so how can we achieve control? First, you need to understand what can actually happen in the attack chain afterwards, right? And how does that speak to your state of environments and your technologies and whatnot, right? Then you implement, we'll go into it, but the risk-based deployment model, which has a specific purpose from an architecture perspective, and then you implement controls that reduce the residual risk, okay? So to understand the risk-based deployment model, you need to understand how to interpret risk. And to interpret risk, you may quantify it and measure it differently, but you need to account for volatility. And what does that mean? So here you're seeing 4 factors: external risk, software risk, data risk, and licensing risk. External risk speaks about your providers when it comes to third parties, right? Do you understand their practices? Do you understand their, what they can produce, right? Like, for example, can you actually get SBOMs from them, right? Can you actually do provenance attestation to what they have produced? With open source, you have scorecards as an example, right? Can you actually see what metadata attributes of that source repository are actually reflective of a security practice, right? Now, software risk is different because you want to account for, yes, known vulnerabilities, but that's not enough. You need to understand high-risk behavior. Like what? Like connectivity to an external source. Now, in the finance industry, we come across a very interesting situation as opposed to other industries, because other industries might be able to say, you know what? I don't want to take in this package because I don't deem it safe enough, and that's fine. But when you are doing business in certain regulatory environments, you're actually forced to take the package, and that's what we call mandated software risk. Sorry, mandated software artifact, right? And the reality is that you need to manage the risk, because I want to speak about my country, but let's say you know that if you go to Mexico and you order tacos, it's a risky situation. You never know what's going to happen, right? So let's say you're doing business in Mexico and you're getting a package called salsita, and in order to do business, you actually need to use it, right? And you know that that package might contain some kind of high-risk behavior. So what do you do with that? Do you just simply put it all along with the execution environments of your other applications, knowing that it might actually do something potentially harmful? Well, probably not, right? But you need to know how to actually identify it. There's a part of licensing risk, how much of the licenses you are actually willing to work with, right? And then data risk, again, I spoke about volatility, but in reality what that means is, right, nowadays we're using a lot of AI models, right? You don't only have the code from the models, you also have data sets, right? And those data sets can be poisoned, right? Can be biased. How do you identify that they were actually not tampered with to keep on the model, the actual code running as it should, right? So this accounts for all of this, right? And this is the breakdown of your risk profile, if you will, that you need to identify. So questions before I move on? No? All right, let's move on then. So what you are seeing here is basically the risk-based deployment model. And what this is calling out is that all along the supply chain, you have opportunities for prevention, detection, and remediation. And you have a set of logging metrics and traceability that you can actually get together to have a full picture of your software supply chain. Now, at the very bottom, you can see external risk assessment, continuous monitoring. That speaks to the external risk altogether. And continuous monitoring, it's a good practice because obviously things change. A vendor might have good practices one day, and the next day they might not, right? Because they got new developers that they don't follow the rules or whatever, right? On the bottom, you see ingestion, procurement, which is calling out the risk assessment. You have inventory and development, and then building, deployment, and consumption, right? We saw that the threats can exist here, and we'll go over how to actually handle them. So questions about this? No? Okay. Seems that I'm not going too fast. That's good. So let's start with ingestion. What do we actually need in ingestion? We need a sandbox environment, because whatever your developer or whomever is actually bringing something into the firm might want to test it, right? And you want that to be in an environment that has a limited attack surface, and that it can blow out and it cannot cause any harm to whatever other systems you have alongside, right? If you think about it, if you have a developer that is bringing new software into their development environment, and that development environment is connected to your network, to the email service, and to other services which that developer has credentials for, then that might actually be a bad thing, right? And as I said, yeah, this enables testing with freedom, sort of speaking. Now, procurement. It doesn't really matter how you're doing procurement right now. Where we're trying to go to is to an automated process for procurement. And in that automation, you're seeking to actually embed a risk assessment. You're seeking to establish a risk threshold evaluation and to enable a risk-based promotion decision. Now, I'm going to explain why this needs to exist. It's because at the end of the day, people that do cybersecurity, us, we're there to enable the business. And we need to let them take the decision of saying, you know what, we have identified risk, and does this still make sense for you to actually do business, and can we actually handle it in the execution environment down the line? And if they say yes, perfect. You take actually an evidence of their reaffirmation of that happening, which takes me to this point, right? I'm calling out exactly what's needed, but at the very bottom, you can see overall process transparency through evidence. Now, that is basically saying, I have a transparency store that logs every single action that's been taken along my supply chain, by who was that action executed and what happened and what's the metadata or the artifact that was produced. If there was an acceptance of risk, there's a risk decision that needs to be actually involved in the transparency log. Why does this matter? Because think about it. If you have a process where someone says yes to a risk, but then that same dependency is being used by someone else, can they know that there was a risk acceptance for that artifact in your current pipelines? Maybe not. That's where this comes in, right? Now, why are all of this is needed? Again, to achieve up-to-date accounting of risk to drive business decisions. That's where we want to get. So inventorying. You have an inventorying request post-procurement. You have a risk assessment validation, which means has this artifact gone through my process, not simply just someone trying to get something into the inventory altogether. Has there been a risk threshold evaluation if it was needed, right? And was there any risk-based promotion decision? Maybe it didn't actually go over the risk threshold, so maybe there was no need for that decision. At the end of the day, you also want risk assessment queuing, which speaks to continuous monitoring, right? That allows you to actually, on the shape of the risk profile, establish what is the cadence that you need to establish to evaluate every single risk profile aspect of that artifact. And then basically you put it into inventory. So again, what is needed? Validation of the evidence of the previous process steps, queuing the risk assessment, overall process transparency to evidence, right? And again, the important thing about this is also that you get time-relevant data about risk exposure, right, along the whole software supply chain. So, building. This speaks to a building pipeline, typically, right, where you have a building request that was triggered by whatever source repository commit or PR, right? You have building. You have risk assessment, risk threshold evaluation, and risk-based promotion decision. That allows the package to actually go into the package registry. Now, bear in mind that building by software supply chain best practices means creating provenance data for that build step, right? Such that it can actually answer to how, when, what were the environment variables, what were the commands, if any, right, that were used to actually build that artifact. So again, same thing, right? We need the same kind of like consistency in every single step of my software supply chain. Any questions so far? No? All right. Now, in deployment, we're going to get an artifact from the package registry, right? And we're going to check the build validation. What that means is, did I get something from the package registry that actually matches the building provenance data, right? Can I actually validate that it's the same package at all? Then I'm going to carry the same risk assessment. I'm going to do the same evaluation, validation, right? And then I'm going to have that risk-based promotion decision, right? Now, can anyone try to guess why the title risk-based deployment model? Where does all of these changes are trying to take us? Anybody want to guess? Automation, yes, that's part of it. Prevention, yes, perfect. Anything else? So, in a perfect world, what would happen is that we have gotten to a point where we know that there is risk with an artifact. We need to manage it, right? And the way to manage it is to spin up an execution environment with risk-based controls in demand. Right? This is where we're trying to go. Well, sorry. This is where we're trying to go. And the need for that is because in the finance industry, as in any other industry, you will have different risk profiles. And the metadata is going to be changing such that your risk profile might be more informed or less informed, and how comfortable you are with that. Right? So, think about it this way, right? Right now, the industry is asking for SBOMs. Okay, SBOMs are great, and it's a very good way to kick off the process of establishing what are you ingesting and what does it contain. Can you actually do provenance attestation? Can you do CBOMs? Can you do AI bombs? Can you do verification? Now, speaking about SaaS, for example, but can you do verification of the processes behind, securing whatever base compute EC2 instance are you standing up, right? So all these metadata will change the risk profile and will ultimately give you a very informed decision of where to put that artifact that you want to execute. Does that make sense for everyone? Yep. All right, so we have 8 minutes. I want this message to stick around, right? Which is, that's what a software supply chain attack is, but also that while ingestion is very important, so it's important to do changes in your internal software supply chain, right? To produce that basically traceability so that you can actually respond better in an incident response, right? Now, you may be wondering, okay, Abdullah, can you give me more concrete steps to actually kick off these changes? And I'll say yes, because after these questions slides, I have put an annex of source repository, building environment, package registry, in deployment environment, controls that you should be looking for, at the very least, right? So again, you can download these ones from the schedule website, and you can actually go through them yourself. But yeah, with 7 minutes for questions, 7 minutes and a half. Any questions? Nope. Simon.
So when you get a known issue, so you've gone through your risk assessment, it's obviously going to be variable, because if you get an issue, then you go back and you look at your controls to adjust that risk profile.
Right.
So I'm just intrigued as to how deep you think this might go. And I guess it might go as deep as you prefer. For example, you might be looking at right back to the NPM and who actually put that code up and what was their user account, and is that a trusted account you've known of?
Correct.
So how far do you go with this, or is it as far as you can?
I think, yeah, there is a line between practicality and completeness, right? The reality is, like, if you think about it, right, in the open source environment, we don't have a clear understanding of trust because of the nature of identities. What happened with the XYZ attack is that there was an identity tied to an allegedly actor, right, that took advantage of open source general practices, which is contributing, building trust in the community to then actually execute something badly, right? So by nature, that becomes complex because then we would kind of like need something on the likes of decentralized identities to actually establish that trust, if you will. But we're not there yet. Does that mean that we don't do anything about it? The answer is no, right? You define this risk profile and you inform it as much as you can. The same is true with providers, right? They might have different levels of maturity in their current SDLCs to be able to provide some kind of metadata for you to attest, right? It might be SBOMs initially, great. It might be actually provenance attestation, but at what stage, right? And with what cadence can they actually update it, right? Is it going to be on every single release, or is it going to be publicly? Is it going to be privately? And you actually have to establish a monitoring cron job to actually pull that and do the comparison.
So I wonder whether we'll end up with primary repos actually asking the developers to make a paper. So it might be a zero paper to validate, because they then know the bank has validated who they are.
Yeah, I think ultimately it comes down to how much growth is there for us to mature in the industry. A lot, right? And I think part of the responsibility we have is to actually contribute to that. There are means to do it. There's OpenSSF, right? Now, OpenSSF might be somewhat US-centric, but the reality is that we need to also look to the alternatives that exist in other regions, right? And how we actually can contribute back to that. But yeah, that would be my way to address it. Anybody else? Any other question? Yes?
All of this looks amazing, and every bank has to do it. We work for same one, so I kind of know how tedious this is. But how much do you think, as a security architect community, invest into automating this? Because this can lead to a software development style where a developer would just quit writing code. Because it does become very tedious. Every step and every level, if there's no automation or something provided, it's
So if you notice, the whole point of this automation is not actually to produce friction for the business, right? Which at the end of the day sometimes becomes a primary benchmark for the developer in terms of his day-to-day job or her day-to-day job. So we want to try to ensure that, but I also want to kind of like pull the community away from just thinking along the lines of CI/CD pipelines, because the reality is that these processes happen even before that, right? And we're seeking automation to reduce man-driven mistakes because of exhaustion or lack of knowledge, right? To evaluate, for example, repository in GitHub and not knowing where to find the actual license in the repo, right? As an example. So I guess it's twofold, well, threefold, I would say. SWAPs are not enough, and we need to keep going, right? There's so much job that can be done in the ingestion, but that we can surely do internally as well, right? And automation should be enabling the business to thrive, right? But also to ensure that security enables the business to go forward too. So that's how I would put it. Any other questions? Yes.
Do you think any industry standard to do the risk assessment, or what criteria you are using to assess whether you are high risk or low risk?
Can you repeat the question? Sorry, I couldn't hear.
Yeah, any industry standard or framework that you have applied to perform the risk assessment?
We don't have a standard per se in software supply chain right now. I think the closest might be Salsa and S2C2, I believe, from Microsoft that donated to OpenSSF. But they will all speak, like, for example, Salsa level 3, which is the highest, stops in the building pipeline. It doesn't go to deployment, right? Now, no one is pointing fingers. That's where we are at the moment, right? But those are best practices. It's not standards practices. And these practices may allude to DevSecOps practices, right? Like, if you think about it, just simply, are you able to identify a privileged actor that actually tampers with the source repository configuration? That's a DevSecOps practice that can manifest in enabling a software supply chain attack, right? So the short answer is there's no standard right now. We're trying to do our best. There's an accolade of information spread out in the industry to follow best practices, but I think at the end of the day, you need to choose your fights and where to begin to, right? Like, there's a primer for these to work as well. Think about it. Like, are you in a position to identify a process identity in your company right now? What that means is, are you sharing, for example, credentials at the project level such that every single instance of a CI/CD pipeline is using them? And what does that really mean? It means that you can actually not pinpoint to the actual execution that might have been tampered with, right? So it changes big things in your company, yes, but at least I'm hoping that I can give you enough to get the ball rolling with this. Yeah, any questions? Any more questions?
Question. Sorry.
Yes.
How AI increases the complexity of supply chain, but also can be used as a mechanism for the detection?
Great. So it's a great question. So what I put on the slides right now, the risk model does account for AI in terms of what are the components and how can actually risk can manifest in that, right? That's not exactly the same pipeline or ML SDLC, if you will, right? Sorry, ML LDC, life development cycle, right? So there's actually an article by Google speaking about AI supply chain security, right? But at the end of the day, I think the important part is the practices altogether. It doesn't really matter at what stage you are. It may be actually at the part of reinforcement learning, right? But the fact is, every process that happens through it should be actually reflected in the transparency store. Okay, I think my time is up. So thank you very much for your time.